Hello, welcome to another tutorial in Rhino. Today we're going to be looking at how to basically test different objects through geometric properties. In this case, it's going to be inclusion both three-dimensionally and two-dimensionally, and then what you can do with those. So this should be a pretty short and simple one. I have two scripts here. One is going to be this two-dimensional one. I will focus on it first, and then the other up here is a three-dimensional one. I'm just using random populations, so don't expect these to be super practical scripts as is, but this kind of tool will allow you to be able to test whether or not there are, if you have a data structure or a set of data that is outside of the realm of what you're really looking for, you can basically just create, some sort of limitation that's like, all right, I want to exclude the rest of this other stuff. So just as an overview of what these scripts look like, the one I have here has a bunch of curves. It's going to have one that populates things in 2D, but then it's going to have a bunch of other curves that we're testing for inclusion. Now this is going to be multiple things. That is why we start to get this data tree over here. But we'll be using the point and curve tool, just a Boolean and col pattern. We'll be making little pathways from them, and then I'll be putting it back together in order to make actual pathways. So this would be like sidewalks. It's kind of like what happens to the McCormick Center on IIT's campus, but not exactly. It definitely doesn't look as good as that, but it's kind of a conceptual thinking device for that. And then in 3 dimensions, we are going to be looking at, once again, another 3D populated thing. It's just going to be a box. And we're going to be looking for 2 different boxes here that we're going to be using point and brep instead of the region tools. And then culling from that. And then we'll be just drawing some simple lines from it, or we'll be seeing how we can make those data sets match until they're the same length, essentially. So we'll start down here. First, we're going to make a curve that is going to be, really it could be anything. So we'll do something loopy because that's fun. And we're going to set our first one to this. So you'll notice doing something loopy here has actually still resulted in this kind of weird bound. What the populate 2D looks for a rectangle that's two-dimensional. Right now, it's not finding a rectangle, it's finding this curve. If I make a rectangle instead, like, let's do a bigger one, like this, and then set this one as the one curve, you can see that we've got everything within this area. That's fine. Let's use this other curve here in order to create one of our first testers. So we're just going to put this one curve in, and you'll notice that I've only got one of the 3 here. They're listed in order here. You'll notice that these 2 things down here are still kind of broken, but the stuff up here seems to be working just fine. I'm just going to plug into this little point parameter to show that whenever I am looking at just that first set of points after this col pattern, we're able to start seeing things get included or excluded based on their proximity, or if they're inside of this tool or not. Let's make a couple more curves. I'm just going to copy and paste these because it doesn't super matter for what we're doing that they're any particular shape. So we'll just do that curve here, and then this curve here. Okay. So now you'll see that all of these are connected. So if I individually start putting things into each of these, it's starting to include them. So just to frame like what's happening here in the middle, we've just put these different curves into this tool. We've grafted this up so that our data structure has its own separate list for each curve, which means that our resulting things are all going to be within their curve. So it's testing, in this case, these 62 points, whether or not they are inside coincident or inside, or outside coincident or inside. So zeros, ones, and twos. This is a bit different than how the BREP one will work, where it's really just using zeros and ones as true and false. In our case, we're just looking for if they're directly inside. So they work like Booleans, because if you have something that's a 1 or a 2, it will just read as true, while the 0 will always read as false. But the reason the list is 62 long is because it's testing everything here. If we increase the number of points that we have, and I really should put a data dam or something further down on this script because it's taking it a little bit to think. There we go. You'll notice that our result here increases to the 151. So let me lock this real quick. And we're going to go back down to, let's do 47 because there's no reason to keep it that complicated. So we still have points in everything here. This one only has 1 now. This is 4. This one has like 8-ish. So yeah, these resulting numbers in the panel are just going to look like zeros, ones, and twos. And so if I make another corresponding panel here and plug it in, you'll see that 2 is true, 2 is true, zeros are false. I don't believe I have anything coincident on 1, but those would be true as well. Okay, and then of course the call pattern, you're just taking this true-false list. In our case, it's the same data structure in order to call it out. And because we have 3 separate lists, we just explode the tree. I'm just using this point tool up here so that I can use something quickly to look at, if my inclusion pattern is working or not. So that's basically it for testing in 2 dimensions. It doesn't have to be anything complicated. In our case, we're actually going a bit further and doing something with these. So we are taking the first set of points in A, and then the points from B here are going to be zeros and ones. We're going to be creating lines, and actually, there we go. Wasn't showing up when I click on this because I have the tool hidden right now. But you can see how this one works, and then this one takes all the points from the other one, and then this one will take all those final points from here. You'll notice that just by the nature of having, even though this is grafted, I only have one thing in B, so it's really only one set of data here. That's just the nature of how this works. We'll graft these back together so that we can do a simple tool. So we'll switch to the little green guy here for what we're selecting. So these are all of our pieces. We're looking at offsetting the curve. I am basically just going plus and minus, in this case 3, in order to go around this, so that you'll see the original curves here and then these curves around it in order to make little sidewalk pathways. It makes a little bit more sense here when you start getting up high to this. You have lots of pathways, but they start to be incredibly redundant. Finally, on here we take this where it's all one curve for each thing, and then we're going to trim the tree. We're doing this because the offset is from these 2 values, grafting it again. This is going to take off that top branch, and it's going to just make sets of 2, so the part that's -3 and the parts that +3 offset, and then we're going to loft them. And so this is essentially just making actual pathways. If we want them to all read as the same thing, we can do a region union. This is a little bit intensive, but you can kind of see the line work now makes everything a solid object, or a solid polyline. And then we do the boundary from here. This is just a little bit cleaner than having them all lofted together with these extra intersecting lines. The testing portion of this one happens all back here. So none of the, actually even before that, really, within the call pattern, this point and curve. And then this is just us doing something with that information. Not that important, but just an idea of something you could use by testing for certain points. We're going to go ahead and hide all these. So our next script is going to be using three-dimensional objects. So in our case, we're going to have to, we can hide these too. We're going to create some boxes. I always use the 3-point box because it's the most familiar to me. It doesn't matter where we're putting these since we're going to be testing with them, but we do need to select this and set one rep. So now when I select here, you'll see that there are points just scattered across this. We're going to drop the count of points just a little bit for my computer's sake. We want to create 2 more boxes to just test within. So we're going to do box again. This one will be a bit smaller. I'm just holding shift to keep things orthogonal at the beginning. We're going to do this one a bit larger. Okay. So let's move this one. We'll move it a little bit out, and we'll move it up some. And we'll move it a little bit out. Just, there will be less things inside of it. My computer will be happier with that. And same thing here. This box is smaller. We will keep it kind of down here and mostly inside of it. Okay. So yeah, you can see we've got some points above this one. We've got some points to the side of this. So it's unlikely that there's a special case here or anything. Just because of the way that I've set this one up with this list length down here, I'm going to do my bigger box up top. You can obviously flip this if you want to pretty easily. So we're going to do set one brep here. And so this one brep and this one brep, we're testing all the points inside of them. And let us also, hopefully this looks right. Start making it look included. Unhide some things. So we're looking at a cull point list now. So if we look at this set of points that are all scattered in here, we can see that this is now testing for all these points. If we move this rep that we're referencing, it'll include a different set. Okay, so let's do this second one. And just the same way, it's going to go through this whole process. We will make these visible again. I don't need the tester to be visible. I just need the... So yeah, we've got the points there, and we've got the points here. So from here, we can do something similar to what we've just done. We're just going to take points from each of these locations. We're going to put them in their own list and then connect them with points down here. This is going to create lines, like groups of lines to all the other points because of the way we have it grafted. If we don't graft this, then it'll be a little bit more straightforward. You'll notice that there's one point with a lot of data coming up to it right now. That's just because we have more points in the top box. If we need those things to, still say random, but not like hyper focus on one thing, we can repeat the list over and over again until it's the same length, which is exactly what we've done here. We've taken the larger list, measured it. We're telling it to repeat the data until it's that long from the first list. And so this looks somewhat more similar to what we just did in 2 dimensions. But once again, 3 dimensions just gets a little bit hairier a lot faster. Obviously, there are probably ways you could use this as a conceptual driver or as a way to talk about sight lines or visibility between different things. But as it is, this isn't the most practical script. This is really just showing you how to get a set of point, another set of points, and things that you can do with them. In this case from 3-dimensional space, but down here in 2-dimensional. Okay? I hope that helps, and take care.